The cost C in dollars of building a house is related to the number K of carpenters used and the numbers E of electricians used by the formula C equals 15,000 plus 50K squared plus 60E squared. If the cost of the house is fixed at $200,000, find dk over dE. In this equation, C is the cost of the house, which we assume fixed at $200,000. K represents the number of carpenters, and E represents the number of electricians. We're looking for dk dE, the rate of change of the number of carpenters with respect to the number of electricians when there are 15 electricians. We start with the equation C equals 15,000 plus 50K squared plus 60E squared. We want to take the derivative with respect to E. Therefore, we set up d dE on the left and d dE on the right. On the right, it is the sum. The derivative of the sum will be the sum of the derivative. On the left, C is a constant. The derivative with respect to E of a constant C is 0. The derivative of a constant is always 0 with respect to whatever variable. The derivative with respect to E of 15,000 is 0 because 15,000 is a constant. The derivative with respect to E of 50K squared, 50 is a constant multiple, we rewrite it. The derivative of K squared is 2K, so times 2K. For the variable K, we're taking the derivative with respect to E, different variable. We have to use the chain rule. Implicitly, this is dk over dE. And lastly, the derivative with respect to E of 60E squared. 60 is a constant multiple, we rewrite this, times the derivative of E squared is 2E, and this time we do not need to multiply dE over dE because dE over dE is 1. Putting these together, on the left hand side we have 0, on the right hand side we have 0 plus 50 times 2 is 100, K dk dE plus 60 times 2 is 120 E. And we're looking for dk dE. And so we will keep 100K dk dE on the right hand side, and we move everything to the left hand side. And the only term that we will need to move is 120E. We then isolate dk dE. dk dE is negative 120E over 100K. We're looking for dk dE when E equals 15. We don't have K though, but that is where 200,000 comes in. We go back to the original function. We see that the cost is fixed. 200,000 equals 15,000 plus 50K squared. We don't know K, plus 60, but we know E. E is 15, so we replace E with 15. We will move all the terms without K to the left side. 200,000 minus 15,000 minus 60 times 15 squared equals 50K squared. Using a calculator, the left hand side is 171,500 and the right hand side is 50K squared. We then divide by 50 on both sides of the equation. 171,500 over 50 equals K squared. We then take the square root both sides of the equation to get K approximately 58.5662. Even though K is the number of carpenters, but in the intermediate step, for now, we round it to 4 decimal places. Going back to the KDE, when E is 15 and we found that K is approximately 58.5662. This is negative 120, where we replace E with 15 over 100. We replace K with 58.5662. Using a calculator, we will see that this is approximately negative 0.3073, or negative 0.31 if we round it to 2 decimal places. What is the units for this number? The derivative is dk/dE, so the unit of negative 0.31 is the unit of K over the unit of E. The unit of K is the number of carpenters, and the unit of E is the number of electricians. What does it mean? If we were to increase one more electricians, meaning if we hire one electrician, then we would lose or decrease the number of carpenters by 0.31. If we round it to 1 decimal places, then this is negative 0.3, but negative 0.3 is negative 3 over 10. The unit is again carpenters over electrician. Meaning if we hire 10 more electricians, then we would decrease the number of carpenters by 3. Another way to interpret this is that if the cost of the house is fixed at $200,000, 3 carpenters are worth that much as 10 electricians.